Hey everyone. So last module we talked about variables and we talked about operators, which is like doing basic math. We did variable substitution, a lot of sort of math related stuff, adding things, taking a variable and manipulating it, meaning you can change it in some way, shape, or form, that kind of fun stuff. I know you guys think that's a lot of fun. Today, we're not going to talk specifically about code or coding per se, but more about like how to think about a problem. Okay. When it comes to like programming, you'll notice I don't give like quizzes or anything. Even if this was like a live class, I don't give like, quizzes and things like that because at the end of the day, I don't really care if you memorize this or not. That's not really at the end of the day my concern. What I'm concerned with, or what I want you guys to be doing, is not worrying if you can memorize, what CSS property does this, or, what the circle function does, or something like that. That's inconsequential to me. What I'm worried, or what I want you guys to be able to do, is problem solve. Okay, because at its core, programming is really about solving a problem. You're writing a program to do something, whatever that something is. Add two numbers to each other, make a bunch of circles randomly appear on a page or something like that, right? So let's talk about problem solving. Okay. Um, Problem solving. So there's this quote that I kind of liked. Every problem has a solution. You just have to be creative enough to find a solution. Okay. So, you know, you guys have a problem. Okay. Let me pull it open. Probably should have done this before I started the video, but hey, no one's perfect, at least at all me. All right. So what is your problem? Well, your problem is that you're trying to create, you know, a bunch of circles and shapes to appear randomly, right? That's kind of your problem. So it's important that when you start a problem, that you're answering the correct problem, right? We don't want to answer the wrong problem. So define the problem. What is it that you're trying to do? At its core, I mean, you've looked at some of the examples here. At its core, what you're trying to do is get random things to appear in random locations. Okay. Whether it's a circle or a square or a triangle or, text, it doesn't, that at its core is what the problem is. How do we do that? Okay. It's not about whether it's red or blue or, that's kind of inconsequential. Those are just kind of little things, so if you're defining your problem that way, that's not the good way to define it. So when you're given a problem, try to really think and evaluate the problem. Are you being asked to sort names alphabetically? Are you being asked to place an item into a specific place on the canvas? Now, in my class, I'm pretty specific about what your problem is. I say, do this, do this, do this. In real life, that's not always going to work out that way. I mean, not every client is going to know exactly what they want. Sometimes you're going to have to listen to them and kind of read between the lines a little bit between what they're really asking you to do. Okay. So it's always really important to understand the problem, mainly so you don't waste a lot of time coding things that don't really matter and then might get cut in the end. Okay. Um, there's an old joke riddle. How do you eat an elephant? Or how do you eat an entire elephant, I should say. I even ruined the joke there. And the answer is one bite at a time. And what they're trying to really get at is that even huge tasks like eating an entire elephant can be made easier if you break it down. So in other words, don't think about eating an entire elephant, just think about eating one bite of the elephant. Okay. And then eventually when you have enough bites, you'll have eaten the elephant. And so if you're given a task, a lot of times it might just be easier to break that down into smaller, more digestible, quote unquote, or easier things to think about. Okay. So here's my example. Let's say you're given, you're supposed to build like a tic-tac-toe game. There's a lot of things that go into that. There's the literal visual board. How are you going to do that? How are you going to represent, how are players going to take turns, right? Because like one person goes and the other person needs to go. How does the program know when one person has won? What happens if neither side wins? How are you going to show the visual representation of me putting, if I've chosen the upper left-hand square, how are you going to show that visually? Are you going to show that? You don't have to technically, but it might help the user interaction to show that. Otherwise, it's kind of confusing, right? So all of these things are problems. They're smaller problems, the whole idea of a game, but you got to like break it down. If you guys were, think about, I don't know, even like the most basic of video games, like Space Invaders or something. It's like, well, you need a way for the player to move back and forth. You need a way for the player to shoot, right? You need a way for the aliens to move, down the screen. You need how do we show, or how do we know when a bullet or a missile has hit an alien? What happens when the aliens get to zero? What happens if the aliens get to the bottom? What happens then? How do we know when that's happened, right? So all of these are like smaller problems to kind of think about and trying to find in this case, a code solution if there is one for that. Okay. Sometimes the answer is solving a simpler problem. Okay. So, let's think about like Mario, okay, from Super Mario Brothers. It's like, let's say he has to collect 10 coins. Well, the first thing is let's get Mario to collect 1 coin, just in general. Worry about that. And then once he collects 1 coin, we can probably take that solution and then kind of scale it up, so to speak, so that he can now collect 10 coins, right? Because if you can collect 1, then in theory you can collect 10. And then you'll have to write some extra code that says what happens when he collects 10, right? Or if you're supposed to animate or code a flock of birds, well, how would you code one bird just by itself? And then you can probably apply a lot of that to multiple, okay? So, the idea is like, rather than trying to, solve a complex problem, trying to think about it in a more equal solution, okay? Going back to my idea of tic-tac-toe, usually the idea of tic-tac-toe is you play multiple games of it, right? Well, I wouldn't even worry about playing multiple games and keeping a score until you can even get one game to work. Once you get one game to work, then we can worry about, okay, how do we reset it and play it again? How do we keep score? That kind of stuff. Okay. Um, this is probably going to be the most controversial thing I say, which is don't rely on other people. Okay. In 2025, there's no shortages of places to find code online. And obviously, I know and that ChatGPT and other AI systems exist where you can type in a problem and it'll probably give you some sort of code solution for that. Okay. And to be perfectly honest, if this was like an advanced computer science class, I actually wouldn't even really care if you use ChatGPT. Okay. At least as like a reference point. The reason why I don't want you to do that at this level, and here's the reason, there's a couple of reasons. One, ChatGPT is actually not always correct, so you can't always trust the results it gives you. But let's even pretend that it is correct. Okay. The reason why I don't want you guys to do it, and I kind of explain this a lot, I want you guys to understand how coding works. And I don't mean like, I don't care if you remember whether there's a semicolon or not. Like that doesn't really matter to me in the long run, because for all I know, they're gonna invent another computer language that doesn't even do that. Maybe it doesn't require semicolons and they do something else. But the concept of variables and functions and all this kind of stuff that has always existed in computer languages. Okay. And if you don't understand that because you just copied and pasted what you got out of ChatGPT, then first of all, it's going to make it harder for you to write programs. It's also harder for you to check whether what you got out of ChatGPT is even correct. You know what I mean? The way I kind of explain it is, when I was in elementary school, it's not like calculators didn't exist, but when we were learning basic arithmetic, like adding and subtracting and things like that, we weren't allowed to use calculators, okay? Because they actually wanted us to understand the principles of adding and subtracting, multiplication, division, that kind of stuff. Now in real life, I used to do taxes for people as a volunteer person. Did I use a calculator? Yes. Yes, I did, because everyone uses calculators, okay? But at the end of the day, I understand how math works, okay? So if I typed 1 + 1 into a calculator and it gave me like, 10,000, I'm not going to just blindly accept that answer because I understand the basics of math. You know what I mean? And that's kind of why I don't want you guys to just copy code or use ChatGPT, or, there's various ways of this. And the answer is like, yes, the code can let you do some quote unquote cool stuff. I'm not saying it won't. I'm sure it will. But I want you guys to like understand how coding works so that if you were to use ChatGPT in the future and you needed to make changes to things, you go, oh, okay, here's what they're doing. I'm going to change this to this and this to this. Do you know what I mean? And then therefore you have more control over it. You're not just literally otherwise you're just a copy paste machine. That's all you can know how to do is like you type something into ChatGPT, you copy and paste it, right? And maybe it's right, maybe it's wrong. Who knows? You wouldn't know because you don't know how coding works. But if you understand how coding works, at least you can like back it up and be like, no, this is correct. I mean, you didn't literally have to come up with the idea, but at least you understand how it works. Okay. I also, just from a learning point of view, think that learning from mistakes is useful because it teaches you how to like not make those mistakes in the future. So that's kind of my spiel. Obviously, I'm sure a lot of you are probably going to use ChatGPT in some way, shape, or form. I'm not stupid, but these are why I don't like students doing that at this level. Now, eventually, when you understand how coding works, yeah, use it because you understand the results that you're getting back and you go, oh, okay, yeah, I can see what they're doing. But you guys are not at that level yet. Okay, that's more like middle to high level computer science person. Like I said, if I was teaching an advanced computer science class, I wouldn't even restrict ChatGPT because at that level, it doesn't even matter as long as the results are correct. But that's not where you guys are. One more thing, and then we'll talk about pseudocode, is, there's many answers to a problem, okay? If the problem is I'm hungry, there are many solutions. Solutions could be eat a burger, eat pasta, eat a salad, those are all viable answers. They're not the same, but they all solve the problem, which is I'm hungry, I ate something, now I'm not hungry anymore. You know what I mean? And in the same way, like, there are different writers, each writer or author has their own writing style, and different painters have different painting styles and drawing styles and all that kind of stuff. Programming doesn't have to be the same. There is no, like, there are many ways of solving the problem. Okay. And that's okay. Now, eventually you can start getting into, well, which is the most efficient way and blah, 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 blah. But we're not going to worry about that. Okay. Right now, it's like, if it solves the problem, it solves the problem. Whether you use 2 lines of code or 200 lines of code, it doesn't matter as long as it solves the problem. Okay. So just understand that it's okay for code to be different. People may come at problems differently over time. And then it's more important to observe that problem and deconstruct the problem, okay, than worrying about whether you're writing the code in the same way someone else is. Okay.